Well, how'd this get here? Maybe you guys solved it for me.
Ooh, that's not funny.
All right, moving on. So we've moved the model over to the side, and now we're going to walk through the left, right, top, bottom, and internal heat generation. For the left-hand side, you have to note that you'll be moving in the x direction, and the area being used will be this delta y, delta z here. When solving for the temperature at node number 2, it will always be last in every equation. From the right-hand side, the surface area being covered will be delta y, delta z, and it is the entire surface area as shown in this equation here. Delta y, delta z, nothing's being divided by any specific dimension. Size, if it were a smaller dimension, if it was a half an element or something like that. From the top-hand side, the distance traveled will be delta y, it is on the bottom. The area will be delta x, delta z, but because the surface area being covered by the delta x is 1/2, you'll be dividing delta x by 2 here, and then you'll have the difference between temperature 1 and temperature 2. Same idea when going from temperature element 3 to element 2. The delta x, delta z is going to be the area dimension, with delta x being divided by 2 because the element is, the surface area is only 1/2 of the delta x distance. And then you will be traveling in the y direction, so the y will be in the denominator, with temperature 2 being at the end. The internal heat generation for element 2 is listed here. And if you note, the element 2 is only going to be half the size of a full element because the delta x is only 1/2. So you'll set all that up and you'll have it equal to 0. With temperatures at 1, 4, 3, and T infinity known, the only unknown is temperature 2 and can be solved.